And you can break this algorithm down into a few steps. And how I like to think about it before going to the lab is, let me first figure out if it's left free wall. Left free wall connotation to me is you need transeptal. It's not going to be very difficult. Let's get the right sheath to put the contact correctly, and we should come home without too much problems. And there you have an OR criteria, That means any one of these, if it's true, it's left free wall. Isoelectric delta wave in lead 1, or a negative delta wave in lead 1, or if the R, not the delta wave, if the R is bigger than the S in V1. Any one of these, if it's true, it's left free wall. If none of them are true, then you go to the rest of the algorithm. So you first got that out of the way, left free wall. Then what's really left? Septum, right free wall, and epicardial. So then go straight away to the tough one, epicardial. Initial delta wave negative. Initial part of the delta wave negative in lead 2. This is the so-called epicardial or venous pathways, and we'll show an example and approach to those. Then you've got that out of the way. All you really have is septal or right free wall. And septal is a beautiful criteria, and I believe the single most useful thing in this whole algorithm. If you have the delta wave in V1 is isoelectric or negative, and then V2, the delta wave is positive. So you transition from iso or negative in V1 to positive in V2, that's septal. Corollary is if it's already positive, however small that positive delta wave is in V1, it's not on the septum. And I think this is an extremely useful thing to tell yourself when you start the case. And then the rest is quite intuitive. It's the way we think of ECGs all the time. 2,3 AVF positive, it's more anterior, it's negative, it's more inferior, and so on.